So 5.5 is all about real exponents, and we're going to first of all review the properties of basic exponents. Then we're going to use those properties to evaluate and simplify, and then we're also going to solve. Main ideas for this lesson. All right, so first let's remember some of our basic rules for exponents. We learned this first semester, we tested over this first semester. You've talked about this in both algebra, geometry, pre-algebra, everything. So here we are multiplying bases that are the same. So we want to combine bases. We do that by adding the exponents. When you multiply bases that are the same, you add the exponent. In number 2, we are dividing bases that are the same. So we combine the bases together and subtract the exponent. In number 3, we are raising a power to a power. So one base has 2 different powers, so we multiply. 3 basic rules of exponents. Then we have 3 more, a little bit more complicated ones. We have power, meaning this is a power of a product and of a quotient. If we are raising a power of a product or a quotient, we are just going to raise each base. Let me kind of clear this out. We're going to raise each base on the inside of the parentheses to the outside exponent. We can only do this with products and quotients. So each base on the inside, we're just going to bring over individually and raise each one. Once we do that, each one is a power to a power. So we just multiply. Now, your final answer should always be as simplified as possible. You should only have one base that's the same. Each base should only have one exponent. All right, so here we have 2 bases in our quotient. We're going to raise each base to the outside exponent. Then you can use your square card or your calculator. 2 to the 3rd power is 8. 5 to the 3rd power is 125. That's as simplified as this one gets. All right, so if you remember, negative exponents are not considered simplified, so I need to rewrite this whole thing. When you raise a fraction to a negative exponent, you can do the reciprocal of the fraction, and that makes the exponent positive. So do the reciprocal and just change the exponent to a positive one. Then we have each base on the inside gets its own exponent, and then simplify. We also covered this first semester, but we just kind of need a little review, kind of jog your memory. You can rewrite any rational exponent using radicals. So I'm going to take my base of 8, bring it over. The denominator moves to the root of the radical. And technically, the whole thing is to the 1st power, but anything to the 1st power is the same. But then we can simplify. The cube root of 8 is 2. So it might be harder to recognize that 8 to the 1/3 is 2. But 8 to the 1/3 is the cube root of 8, and the cube root of 8 is 2. All of these are equivalent. And the most simplified is 2. All right, so when we are simplifying expressions, we cannot leave bases that are the same. We have to combine all bases that are the same. So what's going on with the bases in the numerator? We are multiplying bases in the numerator, so I can condense it into one base of x. When you multiply bases, add the exponents. 3 plus -2 is just 1. In the denominator, the rule is a power to a power, so we multiply. Now we're dividing bases that are the same, so I can combine bases. Since we are dividing the bases, we subtract the exponents. Now, this answer I would consider correct, but typically you do not want to leave your final answer with a negative exponent. So I would rewrite this, moving the whole thing to the denominator, which will make your exponent positive, and we just use 1 to hold that spot in the numerator. The other way you could have jumped from here to this answer, you could see that there's 11 more x's in the bottom than there are in the top, but this should be the best answer for your final answer. Okay, we have a couple of options here. We notice that we have 2 bases that are being multiplied to a power of a product. So we can rewrite each base to the power of 3. So take each base on the inside, raise it to the power of 3. Then we have power to a power, so we're going to multiply. But I don't want to leave my negative exponent. I'm going to leave the t to the 12th alone because it's positive, and then I'm going to move the s to the 6th to the bottom because it's negative in the numerator, so it's positive in the denominator. So all your final answers, you should only see one base of each type, and all exponents should be positive. Once again, we have a power to a product, power of a product. So I need to raise each base inside to the outside exponent. So you can simplify 81 to the 1/4 power because technically it's the 4th root of 81. Here I have power to a power. Remember, 4 times 1/4, multiply the top, multiply the bottom. 4 over 4 is just 1 when you multiply. So this is just t to the 1st, technically. The 4th root of 81 is 3t, because you don't need 1 in the exponent position. So this is the most simplified version of the answer. Okay, here we're multiplying radicals. Now keep in mind, radicals and rational exponents all fall in the same category. Since we are multiplying radicals, I can multiply and put it under one radical. So 14 times 7 is 98. Now I can't take the square root of 98, but there is a perfect square that goes into 98. So we can break it down and simplify it more. The perfect square that goes in evenly is 49. 49 times 2 is 98. It didn't help me up here because neither one of these were a perfect square. But here, 49 is a perfect square, which is 7. But I cannot take the square root of 2, so I leave it 7 square roots of 2. Anytime you are asked for an exact answer, you're simplifying the radical down as much as you can go without using your calculator. These are just evaluate. Anytime you're evaluating, you just want your final answer to be a single value. Okay, so we just should have a single number answer. So let's remember, if you have a rational exponent, you might just want to move the denominator to the corner. you need the fourth root of 625, and I'm going to keep the 3 on the outside exponent. The fourth root of 625 is 5, and 5 to the third is 125. In this one, we are dividing bases that are the same. So I want to combine my two bases into one. Since I'm dividing bases, I'm going to subtract the exponents. 3/4 minus 1/4 is 2/4. But 2/4 can be simplified to 1/2. But the 1/2 power is the same thing as the square root of 16, and the square root of 16 is 4. Everything's getting broken down to a simple value. That's what the directions of evaluate mean. These are a little bit more complicated. Actually, these aren't too bad. We're just converting our radicals back to rational. So the first thing I would have you look at is the cube root of 64. This has a simple value. The cube root of 64 is 4. Then see how these have exponents. We're just converting our radicals into rational exponents. So remember, where does the root number go? Think back here. The root number came from the denominator, so the denominator goes back and forth. This number can either be in the denominator of the exponent or in the root of the radical. So what I'm going to do is put the root into the denominator of each exponent. I didn't do that with the 64 because it wasn't an exponent. I just took the cube root of 64. Now, 9/3, we can divide 9 divided by 3 and get 3. We can divide 15 by 3 and get 5. So this is the simplest answer. All right, and the second one, the 6 just is on the outside, so I'm just going to bring it down. I'm going to move the root to the denominator of each of the exponents. And then simplify each exponent. 14 divided by 7 is 2. 7 divided by 7 is 1, but I don't need to write an exponent of 1. And 12 does not get divided evenly by 7, so I will just leave it as my final answer. Now we're just going to go backwards. We want to rewrite using radicals. So the key to using a radical is this number needs to be the denominator of these numbers. So think back, what was this middle step here? I need to have a common denominator to know what root goes in that corner. So my first step, first of all, the 12 doesn't have an exponent, so it's just going to be brought down. We're not going to mess with the 12. The x's, though, I need to get a common denominator with both the x and the y. Well, what's the common denominator with 2 and 3? I need to make each denominator 6. So I'm going to multiply 2/3 by 2/2. So that's 4/6. I'm going to multiply 1/2 by 3/3. That's 3/6. Then I can move the root, the denominator to the root, and then just bring x to the 4th, y to the 3rd down. So converting from rational exponents into radical form. Now, before I can do that, each base needs its own exponent. So my first step here is to rewrite each base so that it has its own exponent. Then I need a common denominator with 4s and 8s. So they all need to be 8. So I need to multiply this by 2 over 2. So I get 6 over 8. 2 over 2 gets 6 over 8. And the 3 over 8 is already over 8, so I'm just going to bring down the 3. Now I've got my common denominator of 8. Then I'll bring my 2 to the 6th down, x to the 6th, y to the 3rd. You can replace 2 to the 6th with 64. That would be a little bit more simple, but that's okay for me. All right, this is probably the hardest page, so just kind of bear with me. 2 is not going to go in evenly to these values. This does not say rewrite using rational exponents. We're simplifying. So what we want to do is bring out anything that I can bring out of the radical, and anything that can't needs to be left on the inside. Now, I want you to think about, there's a couple of different ways to think about this. 2 can't go into 7, but it could go into 6 evenly. So I'm going to break 7 into 6 and 1. 2 cannot go into 25 evenly, but it could go into 24 with 1 left over. And then 15, I'm going to break t into 14 and 1. So I just kind of split apart my variables. Well, I guess I'm going to save this for my next step. Sorry. Okay, since we're doing the square root, think of it this way. 2 can go into 6 evenly, so that would be r to the 6 over 2. Well, that's just 3. But this 1 is left over because 2 can't go into 1. 2 can go into 24 12 times evenly, but it can't go into 1, so I have 1 left over. 2 can go into 14 7 times with 1 left over. Now, another way you can think of this, if you put 2 over under 7, I see it does not go in evenly, but I could rewrite this as a mixed number. 2 can go into 7 3 times with 1 left over. So if it goes in evenly 3 times, the 3 is on the outside and my leftover goes on the inside. Then you don't have to take this middle step. So 2 goes into 25 12 times evenly with 1 left over. 2 can go into 15 7 times evenly with 1 left over. Okay, so for this one, first we need to condense the radicals so it's one radical just like this one. So I'm going to bring, first of all, the cube root. These are both the cube root. I'm going to combine it into 1. So technically, whenever you see 2 of the same thing, the first thing you're going to do, combine it into 1. So my 2 cube roots go into 1 cube root. Then I'm multiplying a squared times a to the 9th. When I multiply bases, add the exponents. B to the 4th times b to the 11th is b to the 15th. C to the 18th times c to the 1st, don't forget about that 1, is c to the 19th. Then we're going to do what we did over here. I'm just going to use the easy version though. So I'm going to have some that comes out and some that stays in. What's very important, all of these are cube roots. If you forget to bring the cube root down, it's not the same answer. This has to be the cube root. All right. 3 goes into 11 3 times. That's 9 with 2 left over. With B, 3 goes into 15 evenly 5 times, so there's no B left over on the inside. For C, 3 goes into 19 6 times, that's 18, with 1 left over. Final answer. The last page is a solving problem. You're going to solve using inverses. So we're going to subtract 5, which is 729. Now, I want you to think about what's always your goal in solving for x. You've always said in the past, when you solve for x, you get x by itself. Well, if x is by itself, what's its exponent? We need to get our final answer down to x to the first. So this x is x to the 3/4. If I want to get that to x to the first, what I'm going to do is raise it to the power of the reciprocal. Because now I have a power to a power, so I'm going to multiply, and when I multiply reciprocals, I get 1. So I'm raising each side to the power of 4/3 because this side will create x to the first. Now I just need to simplify this. This is the cube root of 729, which is 9. And then I need to find 9 to the 4th. It's 81, carry the 8, 6, carry the 2, 65, 61 is my final answer. So this is kind of a slick method. If you've got a rational exponent for x, you just raise it to the reciprocal, creating an exponent of 1. So what if it looks like this? First, I'm going to subtract 5. Now what I would do, I would rewrite it like this because it's going to actually be easier. What's the root if there's not a root written in? We say this is the square root. That means the implied number is 2. So if I rewrite using rational exponents, I'm just going to rewrite this as x to the 3/2. Because then what I want to do is raise this to the 2/3 power, because then I end up with x to the first, which is just x. 27 to the 2/3, that means I need the cube root. And if you need to rewrite that as the cube root of 27 squared, absolutely. Then the cube root of 27 is 3, and 3 squared is 9.